All right, so we're going to be looking at geometric series. So a geometric series is a sequence when we sum up all the numbers. So as an example, a geometric sequence could be 2, 4, 8. So it's just, comma, dot, dot, dot. It goes on forever with a multiplication pattern of 2. A series is simply taking those values and going 2 plus 4 plus 8. And we just add up all those values. So 6 plus 8, so that's 10, so we get 14. And that would be a series where we just add up the values. Above in blue are the formulas that let us do that. Now they are the same formula, just two different ways of writing it. You can pick any one you want. Doesn't matter which one you use to find the sum of the series. So let's take a look at an example. It says find the sum of the series with the first term being -2 and the last term being negative 93,312, and that total of 7 terms. So our first term is -2. Then you got, term 2, term 3, term 4, 5, 6, and then term 7, like so. Now, we don't know what the multiplication pattern is, and we don't know any of the numbers in between these two. But we can figure out what the multiplication pattern is, and then we can use our formula to help us find the sum of whatever these numbers were going to be. So to find our common ratio, we're going to use the skills that we learned earlier this week. We're going to take the negative 93,312 and divide it by the -2. When we do that, we get 46656. Then we're going to take the term positions, and we are going to subtract those. So 7 minus 1 is 6. So now we're going to make a radical where the index is the 6, and then inside it's 46656. Then we're going to go to our calculator. There we go. Come on. All right. And I'm going to start by typing 6. Then I'm going to hit math. And then I'm going to go down to number 5, which lets me do a radical. And now I have the 6th root, and I'm doing 46656. Hit enter. And so 6 is my common ratio. So 6 ends up being the multiplication pattern from one number to the next. Now that I know what R is, I can go ahead and figure out the sum of this series. So I'm going to use this version of the formula. Right? Term 1 is the -2. And I'm summing up 7 numbers because the last term is term 7. So the first term is -2, parentheses. We know that R is 6, N is 7 because there are 7 total terms, minus 1, all over 7 minus 1. I'm sorry, 6 minus 1. All right, and so 6 take away 1 on the bottom, that's going to give us 5. And then I'm going to go to my calculator. I'm going to type that in. So I'm going to make a fraction. Then I have -2, parentheses, 6 to the 7th power. Subtract 1, close my parentheses. In the denominator, I have a 5. Hit enter, and I get my sum. So the sum of the 7 numbers is -111,974. So if I took all the numbers here that would be in this series, it would sum up to this value. All right. Our next one, this is called sigma notation, and I will show you how to use it. This shows up when we're trying to add up a bunch of numbers. And so down here where we see k equals 1, this is saying that the first number we would plug into k in this expression here would be 1. So we would say, okay, 2 to the 1 minus 1. And then the next number in the series would be 2 to the 2 minus 1. Then 3 minus 1 plus 2 to the 4th minus 1 plus ... And then it ends at 10. So it would go all the way until I get to 10 minus 1. Well, no one wants to plug all the numbers in and then have to add them all up. So we can actually do this much faster with our calculator, because our calculator actually has this sigma function in there. So I'm going to show you how to use that. All right, so going to our calculator, we're going to hit math, and then we're going to scroll down until we see summation. You even see the little sigma symbol there. And hit enter, and now you can it shows that symbol. So instead of using k, like in our example here, I'm just going to use x. So I'll hit x. It started with a 1 on the bottom. On the top, there was a 10. And the expression was 2 and the exponent k minus 1. So we're just going to do 2 exponent x minus 1. And if I just hit enter, it sums up the series for me. I don't have to do any work. It's pretty great. So that means that sigma k equals 1, 10, 2 to the k minus 1 is equal to 1023. So another way of saying that is the sum of 10 terms, because we started at 1, ended at 10, is 1023. Okay. Our next problem says find the sum of, and they give us a series, and they tell us it goes to 12 terms total. So where you can use our formula, the sum u sub 1 r to the n, we have subtract 1 over r minus 1. So we need to know what term 1 is. Term 1 is the 2. We need to know what r is, so we got to figure out that multiplication pattern. So 2 to 6, that looks like times 3. 6 to 18, that's times 3. So r is 3, so we're multiplying by. And then n. There are a total of 12 terms, so n is 12. So I'm going to sum up these 12 numbers. So s sub 12, 2, r to the 12 minus 1 over 3 minus 1. So we will have this. And then I can see that these could actually cancel out. And then it's going to go to my calculator. 3 exponent 12 minus 1 gives me 531,440. And that would be the sum of the 12 numbers that are in this series. Okay, number 4. It says find the formula for the sum of the first n terms of the series. So they give us a series here, 9, take away 3 plus 1, take away 1/3 plus ... And they want us to create the sum formula. So we'll have, once again, this one right here. Right? And I'm going to need to figure out what is r. So if I take the second number divided by the first number, I'd get negative 1/3. if I take the third number, divide it by the second number, I get negative 1/3. So I can see r is really just negative 1/3. Now, I don't know what n is because it doesn't tell me, which is fine. I'm creating a formula, so I shouldn't know what n is if I'm going to make a formula. I do know what the first term is. The first term is 9. So now I can kind of fill in what I know. So I have s sub n equals 9, and then I have negative 1/3 to the n, subtract 1, over negative 1/3 minus 1. That would give me this. Negative 1/3 minus 1 is negative 4/3. Then I'm going to clean it up a little bit by dividing those two values together. So 9 divided by negative 4/3 gives me negative 27/4. So then I'll have s sub n negative 27/4 negative 1/3 n minus 1. And now I have my formula. All right. Our last problem. A geometric sequence has first term 5 and a common ratio of 2. The sum of the first n terms of the sequence is 635. So they're trying to tell me that the first term is 5, the multiplication pattern is 2, and somewhere in the sequence, if I kept adding the numbers up, it's going to add up to 335. Now, since I don't know what n is, I don't know how many terms it takes for that to happen, for it to sum up to 635. So that's what I'm going to do. I'm going to figure out how many terms I need starting at 5 and multiplying by 2 it takes for me to get to 635 for when I add them up. So I'm going to use my formula. You notice everything's coming back to that formula. And my s sub n is 635. U1 is 5. R is 2. I don't know what n is. Minus 1 over 2 minus 1. 2 minus 1 is just 1. So I really just have this. Then I'm going to get n by itself by dividing both sides by 5. That's going to give me 127 2n minus 1. Then I'm going to add the 1 over to get 128 equals 2 to the n. So you could spend time plugging into a calculator, figuring out 2 to what exponent gives you 128, or we can use the numeric solver in our calculator. So if we go to math, go all the way to the bottom, numeric solver, hit enter. I would type in the 128 for equation 1. Then I'm going to type in 2 exponent, 2 exponent x. And then I'm going to hit OK, and then I'm going to hit solve, and it tells me that x is 7. So it takes 7 numbers starting at 5 with multiplication of 2 to add up to 635.